What's going on? General math. We are starting, or not, maybe you can hear me now. We are starting chapter 14. We have diagrams, graph theory with vertices and edges. So a vertice is these little dots that you see. They'd be like the corner of these graphs. And then edges are these straight lines. It doesn't matter what direction they're going. So how many vertices and edges does this graph have? Like we said, vertices are the dot, edges are the lines. Let's count vertices first. We have 1, 2, 3, 4, 5, 6 dots, and we have 1, 2, 3, 4, 5, 6 edges. And then the degree of vertices, so how many lines go to that dot. So we're going to look at dot A here, so vertice A. How many edges go to it? How many lines go to it? Just this one. Whereas vertice B has 1, 2, and 3 lines coming out of it. C has 1 and 2. F has 1. E has 1, 2, 3, and 4. So it has a degree of 4. And then D also has 1. Now moving on to isomorphic versus not isomorphic. Two graphs are keyword isomorphic when they have the same number of vertices, and all correlating vertices have the same degree. Down here in our example of an isomorphic graph, we have 6 vertices, and then they all have the lines don't matter, I guess. So we have 6 vertices, and these have 6 vertices. And then the degree of every dot, so like the dot in the top left in this graph has 1, 2, 3 lines going towards it. And this dot in the top left has 1, 2, and 3 lines going towards it. Same thing as we go around, they all have the same number of lines going into those dots. So since they have the same number of dots and each dot has the same number of lines going into it, even though they don't look the same, they are isomorphic. That's all we care about for isomorphic. Whereas non-isomorphic graphs, either they don't have the same number of dots, they don't have the same number of lines, or even if they do have the same number of dots and lines, all the dots don't have the same number of degree, or they don't have the same number of lines going to them. Right? So an example of that would be like right here, we have 3 dots and 4 dots. So obviously, even though they all have 3 edges, they all have 3 lines, they don't have the same number of dots. And then a graph is connected. So we would call a graph connected if it's possible to travel to a vertex from any of the other vertexes of the graph by moving along the edges. So looking at these two triangles, this graph is not connected because there is no way to get off of this triangle and onto this triangle. So even though the lines overlap, that doesn't matter. You have to go like line, dot, line. You have to go through a dot. Hopefully that makes sense. If not, just send me an email or hop on Zoom.